Example 5. Looking at figure 419 diagram example. In figure 419, current I passes through parallel combination. If the power dissipated in the 5 ohm resistor is 40 watts, calculate the power dissipated in 10 ohm resistors. Solution. The potential difference across the two resistors in parallel is the same. P power is equals to V squared over R. 40 is equals to V squared over 5. V squared, making V squared the subject of the formula, we have V squared equals to 40 times 5, which will give us 200. V is equals to the square root of 200, which is V. Therefore, the power dissipated in the 10 ohm resistor is equals to V squared over R, which is equals to V, which is equals to 200 squared over 10, which gives us 220 watts. Buying of electric energy. Commercial power is consumed in kilowatt hour, kWh. The electrical energy consumption in kilowatt hour is measured with electric meter. From the meter reading, the electrical energy consumption can be calculated. In Nigeria, most of the electrical energy supply is produced at the Kainji Dam. It is then distributed and sold in kilowatt hour units by the Power Holding Company of Nigeria. 1 kilowatt hour is the quantity of energy supplied by working at the rate of 1000 watt per hour. 1 kilowatt hour is equal to 1000 watt hour for 1 hour. 1 kilowatt hour is equal to 1000 times 60 times 60, which is equal to 36 times 10 raised to the power 6 joule, or 3.6 megajoule. Example 6. Calculate the power consumed by an electrical device of resistance 40 ohms connected to a 240 volt main supply. What will be the total cost of using this device throughout a month of 30 days at a cost of 5 kobo per electrical energy unit? Solution. Power consumed is equal to V squared over R, which is, by substituting the values, we have 240 squared over 40. Energy consumed in 30 days is equal to V squared T over R, which is equal to 240 squared times 30 times 24 all over 40 times 1000. Cost at 55 kobo per kilowatt hour. We now have 240 squared times 30 times 24 all over 40 times 1000 times 5, which give us 55,184 kobo per kilowatt hour, of 51 naira 84 kobo per kilowatt hour. Example 7. If PHCN charges 5 kobo per kilowatt hour, what is the cost of operating for 24 hours? A lamp required 1 amp on 200 volt line. Solution. Power capital P equals to voltage capital V times current capital I. P is equals to VI, which is equals to 1 times 200 watts, or 0.2 kilowatts. Energy consumed in 24 hours is equals to IVT. Substituting the values, we now have 0.2 times 24, which will now give us 4.8 kilowatt hour. 1 kilowatt hour equals to 5 kobo. 4.8 kilowatt hour is equals to 4.8 over 1 times 5, which is equals to 24 kobo. Shunt and multiplier. To convert a galvanometer to ammeter, we connect a low resistor ROS called a shunt in parallel to a moving coil ammeter, galvanometer in bracket. Figure 420 shows a low resistance shunt. To convert a galvanometer to a voltmeter, we add a high resistor RS in series with a moving coil, or the galvanometer. The resistance capital R is called multiplier for the instrument. Figure 4.21 shows a high resistance shunt or multiplier. Example 1. A millimeter of resistance 5 ohm and full scale deflection or 50 milliamp is to be used to measure a potential difference of 50 volts. Calculate the resistance of the multiplier. Figure 4.22 shows the diagram of the question. Solution. The value of the resistance S is required. 50 milliamp is equal to 0.05 amp. V is equal to IR. Total resistance R is equal to V over I, which is equal to 50 over 0.05, which is equal to 1000 ohms. R is equal to 1000 ohms, but S plus 5 is equal to 1000, making S the subject of the formula. Is now have 1000 minus 5, which will now have 995 ohms. Example 2. Convert 1 to 10 milliamp galvanometer with a coil resistance of 30 ohms to a 0 to 10 amp ammeter. Figure 4.23 shows the diagram. Solution. 10 milliamp is equal to 0.010 amp. The current IS through the shunt S is 10 minus 0.010, which is equal to 9.990 amp. Potential difference capital V across the shunt is the same as the across the coil, which is given by V equals to 30 times 0.010, which equals to 0.30 volts. The resistance of the shunt S connected in parallel must be therefore be S equals to V over IS, which is equals to 0.30 all over 9.990, which equals to 0.03 ohms. Example 3. When a galvanometer shunted with a resistance of 0.05 ohm, it gives a full-scale deflection for current 2.0 amp. When a resistance of 495.05 ohm is placed in series with the galvanometer, it gives a full-scale deflection for 10 volts. Calculate the resistance of the galvanometer and the current required to produce a full-scale deflection when no resistance is connected. Solution. Let ROG be the resistance of the galvanometer. Let I be the current passing through the galvanometer. So I ROG is equal to 0.5 in bracket 2 minus I. This will be our equation 1. I in bracket ROG plus 495.05 is equal to 10. This is our equation 2 from equation 1. I ROG is equal to 0.1 minus 0.05 I. I in bracket ROG plus 0.05 is equal to 0.1. I is equal to 0.1 all over ROG plus 0.05. This is our equation 3. Substituting 3 into 0.1 over ROG plus 0.5 in bracket ROG plus 495.05 is equal to 10. 0.1 ROG plus 49.505 is equal to 10 ROG plus 0.5. ROG is now equal to